Dear students, in this class let us discuss about the eigenvalues or eigenvalues and eigenfunctions corresponding to an integral equation. So, first we consider the homogeneous Fredholm integral equation. Homogeneous Fredholm integral equation is of the form g of x equals lambda integral a to b k xt g of t dt. If lambda equals 0, what happens here? When lambda equals 0, then the equation reduces to, if lambda equals 0, what happens? If lambda equals 0, we have g of x equals 0. Means the given equation, suppose it is 1. So, which is the solution? Lambda equals 0 is nothing but a solution of this equation 1 or the given equation, which is called the zero or the trivial equation of g of x equals, so the trivial solution of the equation g of x equals lambda integral a to b kxt g of t dt. First we consider the homogeneous Fredholm integral equation, that is g of x is lambda integral a to b kxt g of t dt. When lambda equals 0, what happens here? G of x equals 0. So lambda equals 0 is nothing but the solution of this equation, which is called the zero of the solution, so zero of that equation or the trivial solution of the given equation. Okay. Now, the value of this parameter lambda, the non-zero value, the value of that parameter lambda for which the given equation has a non-zero solution. This, if lambda equals 0, which is called the zero or the trivial solution of the given equation, the value of this parameter lambda for which the given equation has non-zero solution, then that value is called eigenvalue of the given equation. Means the value of the parameter lambda which gives the non-zero solution of the given homogeneous Fredholm integral equation, then such values are called the eigenvalue of that equation. Okay. Then for every non-zero solution, which is called the corresponding function, every non-zero solution of this equation is called an eigenfunction. Okay. So now let us discuss how to find out the eigenvalue and the corresponding eigenfunction of the given Fredholm integral equation. So for consider an equation, find the eigenvalue of the equation g of x equals lambda into integral 0 to 1 e power x plus t into g of t dt. So this is a Fredholm integral equation or homogeneous Fredholm integral equation. Okay. G of x equals lambda integral 0 to 1 e power x plus t into g of t dt. Then how to find out the eigenvalue and corresponding eigenfunction? Eigenvalue means the value of the parameter lambda which gives a non-zero solution of the given Fredholm integral equation. How to find out this one? So for here g of x equals lambda into here f of x equals 0, then g of x equals lambda into integral 0 to 1. Instead of a, here it is 0, b is 1, e power x plus t, g of t dt. Means that g of x can be rewritten as g of x equals lambda e power x into integral 0 to 1 e power t, g of t dt. So with respect to this t, e power x then goes outside of that integration, that is treated as a constant. Then g of x equals lambda e power x integral 0 to 1 e power t g of t dt. Okay. Now let c equals integral 0 to 1 e power t g of t dt. Okay. Let c equals integral 0 to 1 e power g of t dt. So what is g of x? That means g of x equals lambda e power x into c. Lambda c e power x. Okay. Therefore, that means what is c? C equals integral 0 to 1 e power t into g of x is lambda e power x into c. So that means what is g of t? It is g of t equals lambda c into e power t. Replace x by t. So it is e power t into lambda c e power t dt. Agreed. So that means c equals integral 0 to 1. So here c equals lambda and c are constants, goes outside of integration. Lambda c into integral 0 to 1 e power 2t dt power t into e power t equals lambda c into e power 2t. Integral of e power 2t is 2t by 2 from 0 to 1. So that means c equals lambda c into e power 2t means c square by 2 minus yes, it is lambda c into it is e power e square by 2 minus 1 by 2. So means c equals lambda c by 2 into e square minus 1. So if that means this implies c into 1 minus of lambda by 2 into e square minus 1 equals 0. Okay, c equals lambda c by 2 into e square minus 1. That means c into 1 minus lambda by 2 into e square minus 1 equals 0. When c equals 0, there are two possibilities. Either c equals 0 or the terms inside this bracket should be 0. When c equals 0, what happens here? G of x equals 0. Because we have g of x equals lambda e power x into c. So when c equals 0, what happens? When c equals 0, g of x equals 0 means it has trivial solution. Okay, trivial solution or 0 of the given equation. So when c is differs from 0, then we have from there lambda by 2 into e square minus 1 equals 1 or 1 minus this one should be 0. So what is lambda there? Means lambda equals 2 by e square minus 1. So this is the corresponding eigenvalue value. This is the required eigenvalue for the given integral equation g of x equals lambda integral 0 to 1 e power x plus t g of t dt. Okay. So lambda is 2 by e square minus 1 means which is a non-zero value, or this lambda gives a non-zero solution for this equation. Which is that non-zero solution? We have g of x equals lambda e power x into c. Then the corresponding eigenfunction for this value lambda equals 2 by e square minus 1 is then g of x equals lambda into c into that one. So it is what is lambda? 2 by e square minus 1. So 2 by e square minus 1 into c into e power x. So this is the corresponding eigenfunction. So this is the method to find out the eigenvalue and the corresponding eigenfunction for a given Fredholm integral homogeneous integral equation. Clear? So first find out the eigenvalue by using this technique. Then after supplying the value of that lambda or the parameter, the value of that parameter lambda, which gives a non-zero solution, then that is known as the corresponding function is called the eigenfunction. Okay, so this is the required eigenvalue and this is the corresponding eigenfunction of the given integral equation. G of x is lambda integral 0 to 1 e power x plus t g of t dt. Clear? Now consider another equation. Find the eigenvalue and eigenfunction of an integral equation y of x equals lambda integral 0 to 2 pi sin x cos t yt dt. Sin x cos t yt dt. Y of x equals lambda integral 0 to 2 pi sin x cos t by t dt. Find the eigenvalue and corresponding eigenfunction. So here This is a Fredholm integral equation, homogeneous integral equation. Why? F of x equals 0. It's of the form g of x, h of x, g of x equals lambda integral a to b kxt g of t dt. Okay. So here let y of x equals lambda sin x into integral 0 to 2 pi cos t yt dt. Agree. Let c equals integral 0 to 2 pi cos t yt dt. That means, what is y of x? So it is y of x equals lambda sin x into c. Okay, from here y of x equals lambda sin x into c. What is c? C, that means the c equals integral 0 to 2 pi cos t. What is y of t? Lambda sin t into c dt. Replace y of t by lambda sin t into c. So that means c equals lambda c into integral 0 to 2 pi sin t cos t dt. Okay. That means c equals lambda c by 2 into integral 0 to 2 pi sin 2t dt. Why? Because we know that sin 2t. What is sin 2t? 2 sin t cos t. Okay, 2 sin t cos t. So introduce some 2 and 1 by 2 simultaneously here. So it is lambda c by 2 integral 0 to 2 pi sin 2t dt. That means c equals lambda c by 2 into, you can integrate, integral of sin t, that is minus cos t by 2. From where to where? 0 to 2 pi. That means c equals lambda c by 4 into, it is lambda c or minus lambda c by 4 into cos 2 pi minus cos 2 pi minus cos 0. So cos 2 pi 1, cos 0 also 1, so equals 0. Agreed. So that means c equals lambda c into 0 means c equals 0. When c equals 0, what happens here? So c equals 0. From here, what is y of x? That implies y of x equals 0. When c equals 0, y of x equals 0. That means the given integral equation has no eigenvalue. No eigenvalue, and that it has no trivial solution. When lambda equals 0, that gives a trivial solution or 0 of the given equation. Here c equals 0, then y of x reduces to 0 here. Y of x equals 0, y of x equals 0 means the given integral equation has no eigenvalue and it has no trivial solution. So there exist such cases. The non-existence of eigenvalue also exists. The non-existence of eigenvalue, such integral equations are also exist. Okay. So here when since c equals 0, y of x equals 0 means it has no trivial solution and it has no eigenvalue. Clear? Now, consider another equation. That is